Today, let's quickly go through the basics of Pandas. So, as a prerequisite, it expects you to know about Python basics. So, Pandas is nothing but a Python library for data manipulation and analysis. So, we can use many functions in data, in real life data, which is very useful, like cleaning, transformation, aggregation, and so on. Also, we can do visualization. So, this is built on top of NumPy. So what's the advantage of Pandas over NumPy is very fast and it uses vectorized operations, which we will see later. Also, it handles labeled data, so which is related to the real life data. Real life data is always labeled like in rows and column format. Also, it has multiple data types, so like age, name, like string and integer. So Pandas handles all of these. So the main data structures we use here is series and data frame. Series is nothing but a single dimensional column like data. One data frame is nothing but like a table which has rows and columns. So just a single column data from the data frame is called a series, which has the values and the index. Index is used to identify each rows. So let's quickly go into the code. So this is the basic syntax to import the pandas in Python. So as we mentioned earlier, series is nothing but a one-dimensional building block. So we have the values and index, which is used to identify these values. And index need not be unique. Like in, if you study SQL, we have the primary key column, which is used to identify each rows uniquely. But here it can be, here duplicate labels and duplicate index can be allowed. So this has to be looked up after in real life. So let's look at the different ways to create a series. So the most common ones are these. So here, as we mentioned, it just has a single list of values. So using this syntax, this pd.series, which refers to the pandas which we imported earlier, we can just use the values inside. So if we print this, we will have the index, which is the default index, which is 1 0. It starts from 0, and you also get the data type of the each values. Alternatively, we can specify the index if you want to use custom index in a separate list, so it will be arranged correspondingly. Or you can use a dictionary key value pair where the keys will be the index and the values will be the values of this series. Also, another method which is scalar broadcast, where this value will be distributed to all of the index. So as we mentioned earlier, pandas main advantage is that we can use multiple data types. So here the values are multiple data types, so if it's mixed, the data type becomes an object. So we have attributes and operations. So attributes and operations are not only for series, it's for data frames too. Attributes are not nothing but just like properties of series and data frame. And operations nothing but functions which we can execute to achieve something, or we need to get information. So for properties, we have to access it by dot operator, like dot values. This just returns the values inside the series or data frame. So for data frame, we use different syntaxes, and for functions, the same dot operator, but we have the function name. And like in Python function, we use open and close brackets to call the function. So that's how operations is being used here. So here we have these two series. Let's look at the basic operations here. Here is a series which has a list of values and the corresponding index. So first, we just print the values of the series S2. So we have this, and next one is we print the indices of the series 2 S2. So mention we use this toList function because it just returns an object initially, which also gives the data type. So to show in a neat way, we just use this function convert to list to just return in a neat format, and the data type is integer for the series 2. So what happens if we add or do any basic operations between two series? So we add these two. So here we have S2, and here we have S6. A, B, C are the indices, and B, C, D. So if we add these two here in Pandas series, only the corresponding indices gets added. So here we have A, but we have nothing matching to A in S6, so it becomes nan, which is like a null value. And similarly for B, we have the matching value, which is 20 plus 1, 21, and C we have 32, and D we don't have any matching here, so D will become nan. So as you can see, instead of like matching with the corresponding matching with the position and doing operations, it just matches with the indices. So this is the property of Panda. So as you can see here, the data type, even though we initialize as integer, it becomes float because this nan object. So this is nothing but a object to represent a value. So this value, the data type of this is float. So that's why whenever a nan appears first in like an operations, so every other data becomes float. So instead, let's say we actually have a value for A and B here, so everything will be integer. So no, nan doesn't appear. So in that case, this will be integer. So next one is vectorized operations. Here you can see that we took a square root and also we multiplied it by 2. So if you just take take an example of the normal Python, S2 is nothing but a list. So we have these values. So if you multiply it by 2, the usual way we do is we just iterate all of this list and we do this operation. But in Pandas, we use vectorized operations. So it's just that every operation in this series just happens simultaneously, which is much efficient. So let's quickly talk about the data frame. So which is nothing but the rows and columns. So here we have two axes instead of one axis. So because we have the rows and columns, so axis 0 and axis 1, which represents the columns, and axis 0 represents the rows. So each column has their own data type. Like in a database, we have age and name, string, integer, and let's say date, which is time, and so on. So this is much practical for real life scenarios. So let's see about the ways in which we can define a data frame. So this is the basic syntax. This one is most common, which is using a dictionary of lists. So we have this syntax data frame. So this is used to initialize a data frame. So inside this function, we have this dictionary which has key and value pairs. So here the keys represent the column names here, and the values here represents the rows, row data. So similarly, we have another method which is using a list of dictionaries. So we have a list which has dictionaries. So each dictionary entry here will have the column name value. So it's like a row wise data insertion. So this is also can be used to create a data frame. So similarly, we have other methods too, but this is what we use mainly. So for attributes of a data frame, we have these. So these are the ones you'll be using mainly. Shape, columns. Shape returns the uh, number of rows and number of columns in the table, and column returns the column names. And similarly, we have the index which just returns the row labels, and d types we saw earlier, which gives the data type. And this values is used to access the actual values inside a particular column or the data frame. So, and these are the other functions which we'll be seeing soon. So here we have a snippet, code snippet. So you see here we have initialized a data frame with the default method which we saw, which is the list of dictionary of lists. So here, like in the similar syntax, we just initialize the column names and we have the values inside. So we used a similar approach here, and we will have this data frame of 3 columns: name, age, and salary. We'll have Alice, Bob, Charlie, and 3 age and 3 salaries. So we have this shape attribute. So what does it return? So it returns the overall shape. So we have 3 rows and 3 columns, so we'll have 3 3. Similarly, for column returns the column names. And index, we don't have a separate index which is a separate index like an separate index column here. We haven't initialized it, so the it returns a default index which is 0 1 and 2. And if you enter the d types, which is returning the data types, you see here it's an object because like it's a combination of multiple data types. And here, if you see here, we have the values. So values is nothing but we return the actual data inside the data frame. So here we can see that for it returns everything row wise. So let's quickly go to the index objects. So index is nothing but identifier for each row, and it's immutable. That means you cannot modify index in place in a data frame, but you can replace it. So we can see these are the common operations. We can set index to a column. I mean, we can make a column as a index to the table. So here we have, let's take an instance, we have this age, salary, and name. If you want to make this name as index column like an identifier, we can use this set index and name, and this function reset index and rename access and reindex. Let's see them inside the code snippet. So here we have the data frame initialized, which has id, column, and name, and age. If you see here, let's say if you want to set this id column as index, so we can just mention set index the column name. And if you want, if we already have this table or any table with the column as the index, we want to remove it and have the default column here, default index column here, like 012. We can just use this function, this operation, reset index. And for renaming the axis, so in default we will have this axis 0 being named because the index column doesn't have a name here. So if you want to set an name for the index column, which is the default parameter is, we can, the default parameter for rename axis just names the index column custom as customer id. So for reindex, let's see, reindex is nothing, this function, this operation is nothing but you can just take the rows of the particular index which is being mentioned in the parameters and have a new data frame which is being printed here. You can see here. So here the index with id 999 doesn't exist, that's why we have nan. But if you have the index already, that's being written here. So here are the basic differences which we discussed. Some of this we discussed earlier. So in this section, let's talk about reading and writing data in pandas. So the different formats in which we can read and write data. So the most common one is CSV. So CSV is a type of data file, as the name suggests. It stands for comma separated value. So all the data and the files are separated by commas, like 50 or so. This is called a separator or delimiter. So this is commas what separates the data here. And for reading data, we will use this function read underscore CSV. So here is the file type. So this is like an analogy. So we can use like read underscore star, where the star usually has the file type. So this is the basic syntax format. Similarly, if you want to convert it, like if you want to save it to any format, we can use this function to CSV or to whatever the data type we have. So let's talk about the important parameters which we'll encounter in read CSV function. So first one is the important file path, so where we can like mention from what file or what URL or what string or string like object we want to read and convert into data frame using pandas. So here, the next one is a separator. So this by default is comma. So as we mentioned, the data which is separated by comma will be storage here. If it's separated by some other symbols like hyphen or dot or anything, we can use that here. So next one is header. The header is nothing but if you have a CSV file where the first row is not data but actually the header, so it has name, age, and so on, and second row is actually the data. So the first row we can use it as a header. So header parameter is used to mention that in order to take a particular row and consider it as a header. So next one is the names. So we can also assign explicit names while reading the CSV file itself in order to assign names. And index column, so if we have the data here in the CSV, if you want to use a particular column as an index, let's say if you want to use id as the column, so let's use this as the index column using this function. We can assign this to any column name, and use calls just mentions that we can just read a particular subset of the columns and ignore others while reading the CSV itself, so that we can save memory. And d type, we can also specify the data type while loading. So because the if we just load everything using read CSV, and while calculating the data type, the pandas uses data type inference, So it actually guesses the data type by seeing the chunks of the data, but it instead of like actually computing the data, which is also like taking it also takes a lot of memory and a lot of time. So in order to save that, you can, if you know the data type of a particular column, so you can just mention it earlier so that it will be quicker. And next one is parse dates. So we have another data type called datetime. So this is a specific format, and if you want to parse whatever given in the CSV into this format which is acceptable by pandas, you can use this one. And we have NA values. So NA values is nothing but if there is any um, value in the column which we want to treat it as a null value. Like if the CSV has a data called like uh, none val, so this is a string. So if you want to use this, if you want to consider this or any other value as NA values, you can just mention it in a list as a parameter. NA values equal to, and the list of the values if you want to, which we want to consider it as null value. And end rows just reads the first end rows which we want to read from the data set CSV. Skip rows, we can skip rows. And chunk size, it's just a way of loading every data in chunks, and encoding is related to the formatting of the files. So let's see this quick data chunk. So here's the main part. So here we use the main read CSV, and this is the file path. And here we can see the data types for the data frame which is being loaded from the CSV file. Here we use some of the parameters. So here the default parameter here, which is the file path, and use column. So here we use just these columns, subset of columns, ID, name, and age. So index column. So here we notice that we want to use this index ID column as an index. So that's why we use this one ID. So here this is used as ID and NA values. So this value NA and this hyphen here, it's being treated as non values. So here we also pre-specify the specify and force the data type as float for the age. So here we can see the result of the query. So let's see parsing of the dates. As I mentioned earlier, the datetime format. So here we read the CSV and we see the data types here. And here we just parse the date directly while reading itself using parse dates parameter, and you can see the data type is datetime, and to CSV is for writing back, and read CSV or read any file name is for reading. So here also we have few key parameters. Index equal to false, this is the main thing which beginners usually miss out. So if we write index equal to false, if you miss this out, we will have like an extra row, I mean extra unnamed column, because it just assigns a new identifier column. So if you didn't specify this, you'll have an extra column. So we need to specify this in order to ensure like whatever we have in the table already, it has a index column already. So if it has index column already, it will be automatically saved. And here is the separator custom delimiter. So if you want to use any other delimiter, we can mention here. And this one is a columns, write only a subset. So this is like similar to use calls in read CSV. And we have in a rep. So this is the string which we can replace it for non values, missing values. And similarly, we have other parameters too, which you can explore. And here's the code snippet. So here we write with extra index column because we didn't mention the index equal to false, you can see the 0, 1 being added. So if we just mention index equal to false, we can see it without the index. And the next file type we're gonna see quickly is Excel files. So here the syntax is read Excel and to Excel. So in Python, you need another engine library to process Excel files called OpenPyXL or any other similar Excel or Python libraries. So here we just first convert this data frame to Excel again, and we read it back just to ensure that the data is what we read from the Excel. So here we can see the parameters, some of the parameters here, sheet name. So we have like different sheets in Excel, right? So if you want to specify a sheet name, we can mention this sheet name here. So if we have sheet name is none, it just reads every sheets into a dictionary of data frames. So Excel is slower than CSV for large data. So also in order to write to Excel, we need to use this function Excel writer in order to write multiple data frames into like multiple sheets into a single file. So this is similar to like file writer in Python, the syntax structure. Here you can see the sample snippet and we have the output for it. Next one is JSON. So for JSON, here we have a caveat. So if you see here the JSON structure, we just have a sample data, we just convert into JSON for this snippet purpose, and we convert it back. So here we have the raw JSON format, which is not a structure which we would expect. So it is a format which has nested dictionary. So in order to convert this, we have a function called JSON normalize, which flattens the nested JSON, which is in this format, into like flat columns, which we expect in the data frame. So this is usually done for the API responses. And next one is SQL. So this one we just gonna see it quickly. So for SQL, we need to establish a connection if you in Python to any database which we want to connect to. And here are some of the functions. So here we have read SQL query. Here we can execute the raw SQL strings like SQL query to in order to query the data. Here the connection represents the connection of the database, which is related to the database um, credentials and actual connection object. And here we have the read SQL table, with this just reads the whole table as such. So in order to convert the data which we have to SQL, we can mention here the CSR database name connection as a parameter. And here we have another parameter if exists. That means if the data already exists, we can reroute it to these three options. It can either be failed by default, or we can replace it, or we can append it. So replace it completely or replaces whatever is in the database. So we use this carefully. In this section, let's talk about indexing and selection in pandas in data frames. So let's look about the basic square brackets indexing. So here we have any data frame which is initialized, we can index with the help of df square brackets in the column. So we have this data frame and we go on the name column. We can write the column name, and we get the single column as series. So if you want to get multiple columns, we can mention it as another parameter here like this. But if you have multiple columns, it becomes a data frame. So we have to square brackets because it's a list of columns. And if we want to do slicing like in string slicing as we have in Python, we can also do that. So this is like slicing with help of the index numbers. So from index 0 to 3, so 3 is exclusive and 0 is inclusive. So we get from 1 sorry, 0 to 2. Also we can have like a filter like a boolean mask, or let's say um, a filter like this one. I want the age to be greater than 30. So we can also have this condition like thing. So let's look at the code snippet here. Also here we have to solve the inconsistency of the square brackets, because it can either say it can we can either select a column, or we can, if we can select a slice of our data by using these indices. So the behavior varies a lot, so that's why we have these two separate functions, a log and ilog, which we will discuss soon. So here we have the data frame here and the indices. So here I print the name column by using the square brackets and having the column name inside. So in order to print the names, and similarly we can select two columns, then we have to have two brackets here. And this is the slicing, so you can see it slices from 1 to 3. So here 1 is starting from Bob and 2 is Charlie, so we have these two. And here is the query which just fetches the data where age is greater than 30. So here's the data. So this is the difference between log and ilog. So log is dependent on the label. So here we see the label names like name or age or anything, or the index. So here we have the index as R1, R2, R3. So that's why we mention it here in log. So in case of ilog, it's just number based like in slicing. So in square brackets, you have to mention the range. So if first we have the log first parameter, which is from A to C, so which just says like fetch everything from uh, R1 to R3, like a label slice in this case. So likewise we have it for 0 to 3. Also here the C, it's also inclusive, but here the number at the end, this is exclusive like in Python, but here in case of log it's inclusive. And let's see a quick snippet here. So here we have this log R1. So here R1 means the first row, which is R1 is the index. So we have the name and age Alice 25. So here it's from R1 to R3. So we have everything because R3 is also inclusive in case of log. And here we have already fetched these rows, but again we have to mention, if we have to mention a particular column, one column, so we can also mention the column name here. So in this case we have age, that means only age will be selected. And here is the boolean mask, or like a conditional filter here. So here where the age is greater than 28, we fetch the name. And this is for ilog, similar stuff. So this is the first row, and this one is exclusive of index 2, so we get 0 and 1. So here we have the another number. 1 means we have here we already fetched the rows 1 and 2, but we want to get the column number 1, which is the age. So that's why we have the same output here. And similarly It also supports negative indexing like Python lists. So here -1 means from the last we have Dave, which is R4. The next one is for scalar access. So scalar means just a single value. So if you want to just get a single value, we can use these two, which is at and I at. So if you want to get like a single value, we can mention the the row name, the row index, and also the column index in order to fetch the data. So here in the data frame, what's in y row and p column, which is 5 in y row. So we have the 5 which is being fetched here. Similarly for IAT, but this uses scalar by position like with numbers. So this is faster than log or ilog if you want to get single values. And here we can just up, this is the function, this is the script to update a single value. So we can assign it to 99. So that's what is being happening here. And next one we're going to see is Boolean indexing, which is these two, is in and between. So here we have the data frame here, just a similar one we discussed before. So if you want to add like multiple condition, if age is greater than 25 and age is greater than 40, so instead of Python where we use like and or, we have to use these symbols, and or and not, if you want to build a logic for filtering. Also they must be wrapped in parentheses. So also if you want to check if a city is present in or is in between like any range or something, you can use these two. So is in NY and LA means if the city is in a, the city is either NY or LA. Similarly for numbers you can use in between. So this is for Boolean indexing law, or which or if you want to include any logic for filtering the data. And the next function is query. So here we can use SQL like or Pythonish filtering strings in order to filter data. Here we have the data frame. So here we want to get the data where the age is greater than 25 and the city is NY. So we have to get this Charlie. So we can write this as a conditional string where using the query function. So age greater than 25 and city is equal to NY. So also we have the data here, data which is being fetched here. Also, if you want to reference a Python variable, we want to use it inside like the Python string formatting. We use the variable inside a string with curly braces. We can use this add symbol in order to reference a Python variable. So here where the age is greater than 30,